Ever wondered what's happening when you press that clutch pedal and move the gear shifter in a manual car? It might seem like magic, but today, we're going to demystify the manual transmission. By the end of this video, you'll understand exactly how you're telling your car what to do. First, let's talk about why we even need a transmission. An engine has a sweet spot, a range of RPMs, or revolutions per minute, where it operates most efficiently and powerfully. The problem is, your wheels need to spin at a huge variety of speeds, from a slow crawl to highway cruising. A transmission's job is to bridge that gap, using gears to change the speed and torque delivered to the wheels, so the engine can stay happy in its power band. Now, let's dive into the core components. Inside that transmission case, you've got two main shafts: the input shaft and the output shaft. The input shaft is connected to the engine via the clutch, and the output shaft is connected to the wheels. On these shafts are a bunch of gears of different sizes, constantly meshed together. You have small gears and large gears. A small gear driving a large gear gives you more torque but less speed, perfect for starting from a stop. This is your first gear. A large gear driving a small gear gives you less torque but more speed, which is great for cruising on the highway. That's your top gear. So if the gears are always meshed, how do you select just one? This is where the magic happens, thanks to the clutch and the shifter. When you press the clutch pedal, you're disconnecting the engine's power from the input shaft of the transmission. This is crucial because it allows you to change gears without a massive gear grinding fight. With the power cut, the gears inside can spin freely for a moment. Now, let's look at the gear shifter. When you move that lever in the cabin, you're actually moving a set of selector forks inside the transmission case. These forks slide a special component called a synchronizer, or synchro, along the shaft. Each gear pair has its own synchro. The synchro's job is brilliant. It has two parts, a collar and a ring. When you select a gear, the fork pushes the collar towards the gear you want. Before the collar engages, a friction ring on the synchro makes contact with the gear, matching its speed to the speed of the shaft. This synchronization is what allows for that smooth, crunch-free gear change we all appreciate. Once the speeds are matched, the collar slides over and its teeth, often called dog teeth, lock onto the gear, effectively locking that gear to the output shaft. Now, when you release the clutch pedal, power flows from the engine, through the input shaft, through your selected gear pair, and out to the wheels. You're now in gear and moving. Let's walk through it. You're at a stoplight. You press the clutch in, disconnecting the engine. You move the shifter into first gear. The selector fork moves the first gear synchro, which matches speeds and locks the first gear to the shaft. You slowly release the clutch while giving it some gas. Power flows, and you're moving. As you gain speed, you repeat the process. Clutch in, shift a second, clutch out. Each time, you're selecting a new gear ratio better suited for your current speed, keeping the engine in its happy place. So, in a nutshell, the clutch disconnects power, the shifter moves forks, the forks slide the synchros match speeds and lock a gear to the shaft, and when you release the clutch, power flows through that selected gear. It's an elegant mechanical dance that gives the driver total control over the car's power. It's a beautifully simple and robust system that has stood the test of time. I hope this helps you understand the wizardry happening beneath your feet and in your hand every time you drive a stick shift. It's a truly engaging way to connect with your machine. If you enjoyed this breakdown, be sure to hit that like button and subscribe for more deep dives into how cars work. Thanks for watching, and I'll see you in the next one.